In hydropower, the water is converted into turbine. Due to turbine, the from the turbine the generator will rotate. So in this, the steam energy, steam turbines are using here, water turbines are used here in hydropower condition. In generating electricity with hydropower plant, and this is the transmission lines. So by using short transmission lines, the power will be transferred from one place to another place. And this is the distribution. In this, we are studying about substation. Here it is 33 by 11 kV substation. That is outdoor substation. So what is substation? So electrical power is generated at generating stations which are located far away from the consumers, and this generated power is transmitted through a large network to distribution station or substation. So in this, the electrical power is generated at generating stations which are located far away from the consumers. The generated power is transmitted through a large network to distribute station or substation. From substation, the power is distributed to consumer. From the substation, power is distributed to consumers. That is known as substation. That is known as distribution. So the assembly of apparatus used to changes some characteristics, that is example voltage, AC to DC, frequency, power factor, etc. of electrical supply is called substation. So the assembly of apparatus used to change some characteristics. So characteristic means the voltage should be step up or step down. It's converted to AC to DC or frequency. So that electrical supply is called substation. What is the need of substation? The generated power must be conveyed to consumer premises with less transmission and distribution losses. The generated power must be conveyed to consumer premises with less transmission and distribution losses. As the generating stations are located far away from the load centers, the intermediate substations are required to deliver electric power to the consumers. So the generating stations are located in far places from the load centers. So the intermediate substations are required to deliver electric power to the consumers. The substation changes the characteristics of electric supply from one to another. The substations are changes the characteristics of electric supply from one to another. So what are the advantages of outdoor substations over indoor substation? So outdoor substation is placed in outside of the outdoor substation and indoor substations are so under the underground substations. So the construction of work required is much smaller. All the equipments are visible and hence it is easy for fault detection in outdoor substations. So all the equipments are visible and hence it is very easy to find the fault detection. The extension scheme is earlier, as no building is necessary, hence less quantity of building material is needed, and erection can be completed with lesser time. So these are different advantages. The construction work is required much smaller because it is connected in outdoor substation. All the equipments are visible and hence it is used for easily fault detection. as no building is necessary, hence less quantity of building material is needed and erection can be completed with lesser time. The extension of scheme is easier. So here it is the underground substation. So in this, the substation is completely built in underground only. Only the incoming and outgoing wires are visible at the at underground level. What are the disadvantages of outdoor substation over indoor substation? The switching and maintenance of equipment becomes difficulty in during rainy seasons. So the switching and maintenance. Switching means so the voltage should be maintained constant. The stepping voltage higher, step up or step down. So the maintenance of the substation will be becomes difficult in rainy seasons and wind seasons. So the switching and maintenance of equipment becomes difficult in during rainy season. The maintenance is more because dust and dirt deposition is more in outdoor substation apparatus. The maintenance is more because dust and dirt deposition is more in outdoor substation apparatus, but indoor substation there is no dust and dirt. So there are prone to lighting strokes. Yeah, see in outdoor substation in sunny days or rainy days, there are possibility of lightning strokes. So in indoor substation they are avoiding the lightning strokes due to underground. So outdoor substation equipments are exposed to sun, hence specially designed apparatus is needed to withstand higher temperatures. So outdoor substation equipments are exposed to sun, hence specially designed apparatus is needed to withstand higher temperatures. In the table indicates the relative merits of indoor and outdoor substation. So here the space required for outdoor substation should be more, but in indoor substation there would be less chance. Less space is required. So but in outdoor substation the erected time is very less because it is visible. But in indoor substation the erected time was very more in indoor substation. Future expansion of outdoor substation should be easy, but in indoor it is very difficult. So for this we have to replace another indoor substation. So this the future expansion for indoor substation should be very difficult, and identification of fault is very difficult in indoor substation, easy in outdoor substation. Operation of outdoor substation is difficult, and operation of indoor substation should be easy. And the maintenance cost of outdoor substation is more compared to indoor substation. So the maintenance cost of indoor substation should be less. The possibility of fault in outdoor substation is less, and the indoor substation should be more. And possibility of lightning strokes, there is a more chance in outdoor substation, less from lightning strokes than indoor substation. And possibility of formation is outdoor substation it is more, and possibility of formation in indoor substation should be less. Possibility of formation of dust is more in outdoor substation. Possibility of formation of dust in indoor substation should be very less. So what are the advantages of gas insulated substations? So it is another type of substation, that is gas insulated substations. So first one, safety of the working staff is more. There are two types of insulators, gas insulated substations. Safety of the working staff is more, and all live parts are insulated. All live parts means there is a conductors, live conductors parts is insulated, and the reliability is more due to more safety. The reliability is more due to more safety. A space or area required is very less, nearly that is 10%. So in compared to gas substations, the less area will be occupied in gas substation, the more area will be occupied in outdoor substation. So very less maintenance is required due to high quality equipment. So in this gas insulated substation, very less maintenance is required due to high quality equipment, and assembly of equipment requires less time. And GIS technology is popular in desert areas. This gas insulated substation technology is popular in desert areas, and GIS substation is enclosed, therefore free from pollution, sound, storms and snow. So these are advantages of gas insulated substation. What are the disadvantages of gas insulated substation? SF6 gas is costly. Procurement and transportation of SF6 gas is difficult. This procurement and transportation of SF6 gas is difficult. It is require a building which is costly and difficult to identify the faults. It is require a building which is costly, difficult to identify the faults, difficult to repair or maintenance due to small area. Difficult to repair or maintenance due to small area. These are the photographic views of substation. These are the another substation. Here it is the one more substation. Here it is the transformer in substation. These are another photographic view of substations. So in this class we are discussing about definition of substation, what is the need of substations, and advantages and disadvantages of outdoor substation and indoor substation, and advantages and disadvantages of gas insulated substation. Once again I am explaining the substations. That is, electric power is generated at generating stations and which are located far away from the consumers. Electric power is generated at generating stations which are far away from the generating stations, and generated power is transmitted to a large network to distribute station or substation. From substation, the power is distributed to consumers. The substation is nothing but the assembly of apparatus used to change some characteristics. That is example voltage, AC to DC, frequency, power factor, etc. of electric supply is called substation. The assembly of apparatus used to change some characteristics. Example voltage, AC to AC, and frequency, power factor. So a substation is defined as the assembly of apparatus installed to perform any one or two or all of the following operations, that is AC to DC. And what is the need of substations? So what is the need of for substations? To switch on and off the power lines known as switching operation, to transform voltage from higher to lower or vice versa known as voltage transformation operation, to convert AC to DC or vice versa, that is DC to AC or AC to DC known as power converting operations, So to convert frequency from higher voltage to lower voltage or vice versa, lower frequency to higher frequency to lower frequency is known as frequency converting operation. And to improve the power factor by installing the synchronous condensers at the end of the line, it is known as power factor correction. So that is voltage means stepping up or stepping down or converting AC to DC. Frequency converting operations, power factor converting operations. So the generated power must be converted to consumer premises with less transmission and distribution losses. As the generation stations are located far away from the load centers, the intermediate substations are required to deliver electric power to the consumers. So the substation changes the characteristics of electric supply from one to another. What are the advantages of offshore substations over indoor substations? So the construction work is required. The construction work is required is much smaller. All the equipments are visible and it is easy for fault identification. The extension of scheme is easier as no building is necessary, hence less quantity of building material is needed. And the erection can be completed with lesser time. So this is the underground substation, and these are the disadvantages of outdoor substation over indoor substations. The switching and maintenance of equipment becomes difficulty during rainy season. So because of the switching and maintenance of equipment becomes difficulty during rainy season. The maintenance is more because dust and dirt deposition is more in outdoor substation apparatus. They are prone to lightning strokes. Outdoor substation equipment are exposed to sun, hence the specially designed apparatus is needed to withstand higher temperatures. The outdoor substation equipments are exposed to sun, hence the specially designed apparatus to needed to withstand higher temperatures. The comparison between the outdoor substation and indoor substation with merits. That is, the space required is more in outdoor substation and less in indoor substation. The erecting time is less in outdoor substation and more in indoor substation. The future expansion is easy in outdoor substation and difficult in indoor substation. The identification of fault is easy in outdoor substation and less in indoor substation. Operation of outdoor substation is difficult and indoor substation is easy, and maintenance cost is more in outdoor substation and less in indoor substation, and the possibility of fault is less in outdoor substation and the more in indoor substation. The possibility of lighting strokes is more in outdoor substation because of they are built in it of outdoor substation. So, and the possibility of lighting strokes is free from lighting source in indoor substation. The possibility of formation of dust is more in outdoor substation and less in indoor substation. The advantages and disadvantages of gas insulated substations. That is, a safety on the working staff is more. So in gas insulated substations, the safety of the working staff is more. All live parts are insulated. So all the live parts are insulated. The reliability is more due to more safety. The reliability is more due to more safety. Space or area required is very less, that is nearly 10%. Here very less maintenance is required due to high quality equipment. Here very less maintenance is required due to high quality equipment, and assembly of equipment required is less time. Assembly of equipment requires less time. In gas insulated substations technology is popular in desert areas. Gas insulated technology is popular in desert areas, and gas insulated is enclosed, therefore free from pollution, soundstorms, and snow. What are the disadvantages of gas insulated substations are? The aseptic gas is very costly. So sulfur hexafluoride gas is very costly. So the gas is very dangerous to for humans. If the gas substation will be blast, the entire city will be danger for this gas. So subsidy is very costly and very dangerous. The procurement and transportation of this gas is difficult. It requires a building which is costly and difficult to identify the faults, and difficult to repair or maintenance due to small area. It is difficult to repair maintenance due to small area. These are the photographic views of substation. Here this is substation. Right. This is another substation. Here is one more substation, and this is the transformer. In substation, that is, we have to stepping up the voltage or step down the voltage. And this is another substation. And in this class we are discussed about the definition of substation and need of substations, and advantage and disadvantages of indoor or outdoor substation, in indoor based on indoor substation, and gas insulated advantages and disadvantages of gas insulated substation. Right. So in this, now I am explaining here what are the equipments used in substation. What are the equipments used in substation? We came to know that the substation needs its function, classification, merits and demerits of indoor and outdoor substation. But we don't know what is the equipment used in substation. So now we are connecting what are the equipments used in substation. Here it is the bus bar. Bus bar is nothing but it is current conductor, like conductor, and is a single breaks isolation switch. Isolation switch is nothing but when it is in open circuit it will be like this. When it is in short circuit, it will be like this. It is break isolation switch. Double break isolation switch. Double break means the is connected like this. Breaking means it is in open circuit, when it is in short circuit the line will be like this. On load switch with earth blade, with load, when the load is connected with that is the switch with earth blade. Here it is the lightning arrestor valve. So these are the symbols we are using drawing only. Lightning arrestor valve. So arcing horns are used in the towers. This is the three-phase transformer, and it is overcurrent relay, and it is earth fault relays. These are the only symbols we are using in substations, and mainly these symbols are used for drawing purpose only, and at the time of nameplate details, we are using only these type of symbols. Now we have to study the equipments used in substation. What is bus bars, insulators and transformers, switch gears, indicating and metering equipment, protected relays, lightning arresters, cables and firefighting equipment. So these are the different equipments used in substation. Bus bars, insulators. Bus bars is nothing but the conductors, incoming conductors and outgoing conductors is known as bus bars. And insulators, so insulators does not follow the current, It is pin type, insulators, suspension type, shock type, transformer which is used to step up the step down the voltage, and switch gear, and indicating metering, indicating ammeter, voltmeter, and protective relays and to tripping the device, lightning arresters to which absorb the strokes, right, cables, and firefighting equipments. If any hazards are applied, hazards are occurred in substation, we are using firefighting equipments, cables, insulators, lightning arresters, insulators, switch gears, right, bus bars, and power transformer, cables, and firefighting equipment. These are the different equipments we are using in substations. Motors. These are the bus bars. Bus bars is nothing but when a number of lines operating at the same voltage have to be directly connected electrically, or bus bars are used as the common electrical component. When a number of lines operating in a number of lines operating at the same voltage have to be directly connected electrically, bus bars are used as the common electrical component. The bus bars are copper or aluminum bars or AA conductors, steel reinforced wires, that is ACSR connectors. So in our practical case we are using only ACSR connectors, aluminum conductor, steel reinforced. We are using only aluminum conductors. The incoming and outgoing lines in a substation are connected to the bus bars. So incoming and outgoing conductors is known as bus bars. The conductors to which several sources or feeders are connected is known as a bus bar. The conductors to which the several sources or feeders connected is known as a bus bar, and it carries heavy current. The bus bar having a very heavy current. These are the tubular bus bars. These are the tubular bus bars. We are not using tubular bus bars. The most commonly used bus bar arrangements are single bus bar system and double bus bar, and a single bus bar with sectionalization and duplicate bus bar arrangement. So in substation we are using different types of bus bars. There is single bus bar arrangement, single bus bar with sectionalization, duplicate bus bar arrangement. And bus bar sizes. The diameter of the tubular bus bars normally employed for various voltages are as follows. The diameter of the tubular bus bars. So 11 kV for 11 kV line, the bus bar size is 38 mm. Aluminized tubes, and 33 kV 38 mm. For 66 kV 63.5 mm. For 132 kV it is 76 mm. For 132 kV it is 76 mm. For 220 kV it is 76 mm. The size of the conductor is normally used for the strain bus bars, or 20 kV 61.0398, that is 61 by ACS conductor. For 132 kV that is 37 by ACS conductor, or for 37 conductor 0.335. For 66 kV that is 37 by 0.27. The size of the standard conductors of the tubes depends on the transformer's capacity. So the size of the conductor should be depends on the kV line of the or transformer capacity. For 11 kV line, the size of the standard conductor of the tubes usually depends on the transformer's capacity. And insulators. The insulators are nothing but it supports the conductors. So insulators support the conductors, confine the current to the conductors. There are several insulators used in substation depending upon the service requirement. So the insulators have two purposes. First one, they support the conductors and confine the current to the conductors. And there are several insulators used in substation depending upon the service requirement. And the pin type insulators, suspension type insulator, strain type or disc type, and post insulators and bushing insulators. So these are the different types of insulators: pin type, suspension type, post insulator, and bushing insulators, and shackle insulators. These are the different types of insulators. These are the different types of insulators. These are the insulators. These are the suspension type insulators or shock type insulators. So each disc containing approximately 11 to 16 kV. Right. So suppose if we are proving that here it is 5 discs, that is 11 kV into 5, approximately it is 55 kV lines or 16 6 kV lines. The voltage should be in 12 kV, that is 66 kV line. And uses of instrument transformers. And the suspension type, strain type, disc type. This for operating voltage about 33 kV. The pin type insulators are economical. So for less voltage only we are using pin type insulators. So above the voltage we are using suspension type or strain type insulators. The suspension insulators are used for above 33 kV lines, and it consists of a number of disc insulators connected in series by metal link in the form of string. Consists of number of disc insulators connected in series by metal link of the string. The conductor is suspended at the bottom of the end of the string. The conductor is suspended at the bottom of the end of the string. The top line is connected to the tower side, bottom of the line connected to the conductor. And the post insulator, it is consist of porcelain body, a cast in on cap and flanged cast in base. And this is the different type of insulator. This type of insulators are directly connected to bus bar, lamp, and bushing insulators. So it consists of a porcelain shield body. It mainly consists of washer at the top and the bottom for fixing the position of bus bars called shell. On mounting, a flange with holes drilled for fixing bolts and supplied with an earth bolts. And shackle insulator, it is designed for low voltages. The insulator is round, has a throw hole at the center to receive a long bolt. It is used where there is considerable mechanical stress or when the angle of transmission line changes. It is used where there is a considerable mechanical stress or when the angle of transmission line changes. It is also used at the end of span of the serial wire service connection to a domestic house or factory. So what are the equipments used in substation? So bus bars, insulators, transformers and switchgears, indicating and metering equipments, protecting relays, lightning arresters, cables, firefighting equipments. Bus bars. So these are the different equipments we are using in substation. bus bars. There is when a number of lines operating at the same voltage have to be directly connected electrically. Bus bars are used as the common electrical equipment. When a number of lines operating at the same voltage have to be directly connected electrically, bus bars are used as the common electrical component. The bus bars are copper, aluminum bars, AA conductor steel wires, this ACS are conductors. The incoming and outgoing lines in a substation are connected to the bus bars. And the conductors to which several sources or feeders are connected in known as bus bar. It carries heavy current. These are the tubular bus bars. The most commonly used bus bar arrangements are single bus bar arrangement, single bus bar with sectionalization, duplicate bus bar arrangement. The bus bar sizes. The diameter of the tubular bus bars are normally employed for various voltages as follows. That is 11 kV line, it is 1.5 inches. This 38 mm aluminized tubes for 33 kV 1.5 inches, 38 mm aluminized tubes for 66 kV line. That is the diameter of the tubular bus bar is 2.5 inches, that is 63.5 mm aluminized tubes for 132 kV line, 3 inches, that is 76 mm aluminized tubes. 220 kV line, that is 3 inches, 76 mm aluminized tubes. The diameter of the different tubular bus bars for various voltages. And bus bar size. The size of the conductor normally used for strain bus bars are for a 220 kV line, that is 61 mm. It is the size is that is 0.398 aluminum conductor steel reinforced. Next for a 132 kV line, it is 37 by 0.427 aluminum conductor steel reinforced. For 66 kV line, 37 by 0.279 aluminum conductor steel reinforced. For 33 kV line, the size of the standard conductors of tubes used depends upon the transformer capacity. For 11 kV line, the size of the standard conductor of tubes depends upon the transformer's capacity. As the transformer capacity is increases, the diameter size and size of the conductor should increases. And insulators. The insulators have two purposes. They support the conductors and confine the current to the conductors. So these are the several insulators used in substation depending upon the service equipment. That is pin type insulator, suspension type insulator, post insulators, bushing insulators, and shackle type insulators. So these are the different types of insulators used in substation. This is the suspension type or shackle type insulators. For operating voltage about 33 kV line, the pin type insulators are uneconomical. Suspension type insulators are used for above 33 kV. For operating voltage about 33 kV, the pin type insulators are uneconomical. Suspension type insulators are used for the above 33 kV. It consists of number of discs insulators connected in series by metal link in the form of a string. The conductor is suspended at the bottom of the end of the string. Post insulators. It consists of porcelain body, cast in on cap, and flanged cast it as on base. This is the one type of cast iron base. So here the bottom of the conductor is connected as cast iron, where the conductor is connected to the top of the insulator. This type of insulators are directly connected to the bus bar clamp. And bushing insulators. It consists of porcelain shell body. It mainly consists of washers at the top and bottom for fixing the position of bus bars or rod and shell, mounting flange with holes, drills for fixing bolts and supplied with an earth bolts, shackle type insulators. It is designed for low voltages. The insulator is round and has through hole at the center to receive a long bolt, and it is used where there is a considerable mechanical stress and the angle of transmission line changes. It is also used at the end of span of the serial wire or service connection to a domestic house or factory. So in this class we are discussing about right, different what is the need of substation, what are the advantages and disadvantages of outdoor substation and indoor substation, and what is the advantages of gas insulated substation and disadvantages of gas insulated substations. Right? Okay, thank you.